Hello everyone. My name is Ali and I'm a lecturer in the School of Computer Science at the University of New South Wales. In today's presentation, we want to talk about Metaverse and the research projects that we are conducting in this area. Let's start by talking about what Metaverse world means. If we break down Metaverse, we have the word meta and verse. As you know, meta means beyond and verse means world. So when we say metaverse, it means a world that is beyond this physical world. There is a physics theory called parallel worlds, which means that there are different worlds and there are different copies of the same person who lives in different worlds. And the concept of metaverse comes from multiverse theory. So metaverse is a world that is parallel to our physical world, and you can make your own avatar and you can have different living in that world. And as I said, it's a world, so it means that you can do almost everything. When we call an environment a metaverse environment, it should have three different characteristics. First of all, it should be a 3D environment that can enable users to do different social activities such as chatting, going to the concerts, going to the cinema, or going to the online classes. Also, one of the most important aspects of a metaverse is sense of immersion. Users should feel that they are a part of a virtual world, and the sense of immersion should separate them from the physical world. So, if, for example, you're playing a multiplayer video game on your computer screen, it's not a metaverse because you're still in your own room and you can see your room environment in addition to your computer screen. But when we talk about metaverse, it means an environment that separates you from the physical world. And when you go to that world, you can't see anything from the physical world. This is the exact definition of the metaverse. In the metaverse world, we see the avatars of other users, the avatar that they created for themselves. And we can have different types of interactions with them. We can talk with each other. We can do a teamwork, such as playing a game. We can go to a classroom and learn something. Or we can join a concert or go to cinema and watch a movie. One of the most interesting features of the metaverse is going to live concerts or cinemas with our friends. For example, you can purchase a ticket for Selenium concert and go to the concert with your friends. For the metaverse concerts, the singer should go to a special concert theaters that are equipped with 3D cameras. Then the cameras generate the 3D model of the singer. Going to a concert in Metaverse is not like watching a live concert through TV because you can see the 3D avatar of the singer and the musicians. And also you can interact with them and the other audience and they will see you as well. It means that you can interact with your friends in the concert theater and you can talk with them. Another useful feature of the metaverse is going to the online classes instead of using applications like Microsoft Teams or Zoom. All the students and the lecturer can wear their virtual reality glasses and then they go to the virtual class and they can see the avatar of each other. They can have different interactions and definitely it can make a more dynamic and engaging class. In addition to going to concerts, Metaverse can be used for going to the cinemas and watching movies with your friends. You can purchase a ticket for a movie, it can be either a 2D or a 3D movie, then go to the cinema. And during the movie, you can talk with your friend, you can even talk with the other people who are in the theater, and you can watch the box office movies in a larger screen while you are with your friends. Finally, metaverse can be used for socialization in different environments, like a virtual bar, a club, a cafe, or even a restaurant. Now let's see how we can go to the metaverse. The key for going to a metaverse world is using a virtual reality headset. In fact, there are two different technologies that can make virtual worlds. As you can see here, by using virtual reality, you can't see anything from the real world and you will go into a pure virtual world. But the augmented reality can enable us to see some virtual elements in addition to the real world. Virtual reality creates a simulated environment, and unlike traditional user interfaces, VR places the user inside an experience. Instead of viewing a screen, users are able to interact with a 3D world and play the role of a character in the virtual world. VR has different usages, such as in 3D movies, in simulators, or in playing video games. Another type of virtual worlds can be created with the use of augmented reality. AR is the combination of virtual reality and the real world, and developers can create images or applications that are blended with the real world. In fact, with the use of AR, users are able to interact with virtual contents in the real world. In addition to virtual reality and augmented reality headsets, there are some headsets that are called mixed reality. And these headsets can be used as both virtual reality and augmented reality headsets, as they can use their external cameras to show the real world environment to users and then add some virtual objects to the real world. Now let's see how we can develop metaverse-like virtual reality-based and augmented reality-based environments. We can develop such environments using game engines. A game engine is a powerful rendering tool that provides features such as animation tools, material design tools, physics and collisions engines, and audio engines that can help to develop high-quality graphical environments and video games. Game engines are a combination of programming environment and a visual interface, and they can facilitate the development process. They provide a powerful 2D and 3D rendering engines that enable us to render the scenes and make realistic lightings and visual effects by writing the minimum code. In the recent years, Metaverse and VR has been used in different fields for teaching. For example, in the area of teaching science, different VR applications are developed by researchers to teach physics, chemistry, or biology to provide the 3D model of different objects to students. On this slide, you can see a good example of using VR in education. The purpose of this system is for teaching the structure of car engine for mechanical engineering students. In this application, students can assemble or disassemble the car engine and explore different parts in a VR environment. Overall, VR is a very suitable tool to make simulations of different situations. For example, on this slide, researchers implemented a virtual reality application for industry education. They simulated some dangerous scenarios of industrial accidents and then developed a VR app to train staff to deal with all kinds of emergencies. Compared to regular training environments that primarily offer theoretical knowledge to a staff, the development team could create a simulation of emergencies that allowed users to move freely, walk around, and engage in various processes. The results of this study showed that the training effect obtained by using VR environment is more efficient than the traditional training methods. One of the best usages of using VR in the area of simulation is simulating labs environment and labs equipment. Although currently there are some applications that run on tablets and computers to simulate lab equipment for chemistry, physics, or medical science, they are not as interactive as VR applications. Sense of immersion that VR environments can make is one of the main benefits that can affect learning performance. For example, in these two examples that you can see on this slide, VR is used in simulating science lab and a manufacturing robot, and the results show that VR can increase learning performance significantly. This study is similar to the study in the previous slide about manufacturing robot, but that one was just a simulation. However, this project enables users to interact with the robot, and it can provide an interactive environment. Another study in VR simulation is a study that is conducted in the area of using VR in surgical simulation. The research team developed a simulation of a surgical training process and combined it with a 360 video. The results showed that users were more engaged in the VR environment compared to the traditional training methods such as watching a video. If I want to provide a summary of the efficiency of VR in education, I can say that the sense of immersion in VR can positively affect learning performance, but it's not actually clear if increasing learning performance is just related to motivation or decreasing cognitive load of users. In fact, it can be said that there is a gap in the literature as most of the studies just evaluated the effect of VR on learning performance and motivation without considering cognitive load effects of VR. Cognitive load theory is an educational theory that focuses on the limitation of our working memory. Based on cognitive load theory, we have two types of memory: working memory that is limited and long-term memory that is unlimited. And when we are dealing with learning a new concept, working memory is responsible for learning the new concept. When we are attempting to learn a new concept, an overwhelmed working memory can lead to a decrease in learning performance. But when the learning content is designed to avoid negatively impacting working memory, learning performance can significantly improve, which allows learners to overcome the limitations of their working memory. There are two different types of load: intrinsic load, that is related to the difficulty of the concept that we want to learn, and extraneous load, that is related to the difficulty of the teaching material. So we can't affect the intrinsic load as it is related to the nature of the material, but we can decrease extraneous load by providing an appropriate teaching method. And virtual reality is one of the keys to decrease extraneous cognitive load by increasing sense of immersion, decreasing split attention, and increasing learners' engagement. Speaking of metaverse and virtual reality, we are currently working on a larger scale project that is called the University of New South Wales Metaverse. We've crafted a virtual city that mirrors the entire UNSW campus. Each building serves as a specific faculty or a school. So, for example, if students go into the building that is related to the School of Mechanical Engineering, they can use mechanical engineering lab equipment and lecture theaters. Also, this environment is a multiplayer environment, which means groups of users can dive in, collaborate seamlessly, and even spot each other's avatars as they navigate the metaverse. In order to evaluate the efficiency of our metaverse project and conduct some projects to discover new aspects about the efficiency of virtual reality, we are designing three research projects. Our first project takes us into the world of mechanical engineering, where students have to mix various materials to make composite sheets. What we are curious about is how virtual reality impacts this process. So we're setting up a virtual reality simulation that lets students collaborate with each other, and then we're going to see how this compares to the traditional method of students working on the same process in a physical lab. Our second research project is quite similar to the first one in mechanical engineering. It's all about using a manufacturing robot to make different parts such as airplane wings or car body parts. In this project, students control a manufacturing robot and they will learn how to program it to create various parts. After this hands-on experience in the virtual lab, we will be comparing their learning outcomes with those of students who have worked with the actual manufacturing robot in the physical lab. On this slide, we have a video demo showcasing our mechanical engineering lab. It shows how students can engage in the process of creating composites by combining various materials. Our third research project is related to medical science laboratory simulation. In this project, we've simulated a PCR machine and replicated the environment of our medical science lab. Within this virtual setting, students can engage in various tests and experiments using the PCR machine to acquire practical knowledge and hands-on experience. As with our previous projects, we will evaluate the learning performance of students who use our virtual PCR machine compared to those who work with a physical PCR machine in the traditional lab settings. This analysis will provide valuable insights into the effectiveness of our VR-based learning approach in the field of medical science. On this slide, you can see a video demo of our medical science lab and the way that the students can interact with a PCR machine. Our research projects differ from similar research projects in several significant ways. Firstly, all our applications are fully interactive, setting them apart from mere 3D movies where students are passive observers. In our applications, students can actively engage with objects, manipulate them, assemble them, and create something new. Secondly, our environments are designed for multiplayer interactions. This means that users can create their own avatars and collaborate with each other, including talking and interacting with the other users' avatars in the virtual space. And from a research perspective, our approach stands out as we are not only evaluating learners' motivation, but also considering the impact on cognitive load. This is in contrast to many other studies that primarily focus on assessing motivation while overlooking the cognitive load effects. In our three research projects, we formulated four hypotheses. Based on the hypothesis, we anticipate that the use of VR can enhance learners' motivation while reducing their cognitive load when compared to scenarios where users work with physical lab equipment or static videos. This improvement can be related to the sense of immersion and the controlled environment that VR offers, resulting in fewer distractions. Also, we hypothesize that incorporating guidelines for operating lab equipment directly within the VR environment can decrease cognitive load and reduce the split attention effect. Regarding developing our Metaverse platform, it is developed with the use of Unreal Engine and Unity Engine. And for the multiplayer feature, Photon plugin is used to enable users to have real-time collaboration. Now let's talk about the methodology and the data collection process of these research projects. As I explained, in these research projects, our Metaverse platform will be utilized. Each experiment will involve 30 users in the control group using the physical lab and 30 users in the experimental group using the simulated VR environment. And a combination of quantitative and qualitative methods will be employed to evaluate learning performance, motivation, and users' cognitive load. All the participants that will be a part of our research will share common characteristics. They are university students, aged above 18 years old, and they will have little to no prior experience with a target lab equipment. It means that, for example, if they want to learn about PCR machine or the manufacturing robot, they shouldn't have any prior experience with a PCR machine or the manufacturing robot. We need to have a homogenized participants so that we can have reliable results. Regarding the process of conducting each experiment, we divided it into three distinct sections: before the experiment, during the test, and after the test. Before the test begins, participants are required to complete a consent form, then fill out a pre-test questionnaire that includes questions about their age, gender, prior experience with VR, and their familiarity with the target lab equipment. During the experiment, we will assign specific tasks to participants and ask them to complete those tasks using the equipment either in the VR environment or the physical lab. While performing the tasks, we will measure successful task completion rates, time duration spent by participants on each task, number of times that participants requested assistance or hints, and finally, any errors that participants encountered will be recorded. Finally, after the test, a combination of NASA TLX, that is a standard questionnaire for measuring cognitive load, and a post-test questionnaire to inquire about participants' experience with either the VR environment or the physical lab depending on their group will be used. The NASA TLX will assess the difficulty of the tasks and the amount of mental effort that users have expended on completing each task. And the post-test questionnaire will focus more on the technical difficulties that users face and their satisfaction levels during the process of performing each task. Although we are still in the process of data collection, the preliminary results from demoing our application in numerous workshops show that participants had positive attitudes toward our system. Many users expressed their opinions about our VR system, our Metaverse platform. They described it as realistic, practical, useful, functional, immersive, and enjoyable. Hope we can finalize the data collection soon and perform the data analysis and share the results with the research community soon. Thank you very much, everyone, for your attention.